What's up, stats? This is Mr. Carlson, C-Squared Mathematics. We are going to be continuing our study through the normal distribution with 5.2 normal distributions and finding probabilities. So yesterday what we did was just kind of analyzed and interpreted the normal distribution. We looked at the empirical rule. We saw how the percentages are affected by moving your standard deviation and mean, but we also saw the standard normal distribution where we use z-scores, where your standard normal distribution, your mean is always 0 and your standard deviation is always 1. And then we found the area that corresponds to any given z-score, either to the left or right or in between. That's what we did for 5.1. We're going to be continuing using z-scores and Desmos, but not by finding areas, but by finding probabilities. So we're going to be using specific examples, big examples, application questions, pulling out our necessary things, the necessary things to use, and then using that to find probability. Okay? So the homework quiz, I'm not going to go through Bellwork because I don't think I have time for that, but I will just give you right to the homework quiz. It's 5 questions, 20 minutes. Get started, review your questions. If you have any partial credit, any decimal places mixed up at all or anything, then let me know. Maybe you forgot a negative or you just rounded wrong or something. Just let me know. I can look at it, but absolutely review your questions and then review your answers and then send any partial credit requests if you need to. After that, print out the note packet for 5.2 if as much as possible, or follow along in your own notebook for 5.2 normal distributions and finding probabilities. So we're going to be asking, how do I find probabilities for normally distributed variables? How do I find probabilities for normally distributed variables? Of course, we're going to try to do that using tables and technology. Okay, but how do I do that specifically? Let's find out. So the guidelines on how to do this, first of all, you can find the probability that x will fall in any given interval by calculating the area under the curve for the given interval. So that's what I mean. When I say find the area, I really mean find the probability. Okay, you can find the probability by simply calculating the area. And we've already been doing that since yesterday for 5.1, right? So to find the area underneath any normal curve, you want to convert the upper and lower bounds to an interval to z-scores. Now, when I say any normal curve, what that means, guys, is really it's not standardized. So if you want to find the area or probability for any curve that's not standardized, what these guidelines are telling you is that you ought to standardize it first by making it into a z-score. After you find a z-score, then you use the normal standard, the standard normal distribution to find that area. And then, of course, that area will be your probability. Of course, you can use Desmos to check your answer. Okay. However, I will kind of caveat this. All right. I will warn you. I will kind of flip back and forth between these steps. Why? Because honestly, if you use Desmos, you don't need to convert the upper and lower bounds of the interval that you're given to z-scores. You don't need to do that. This only tells you in your Math Excel view and example and everything, the book will actually tell you to do that because they're expecting you to use the standard table, the standard Z table that I showed you in the last video. Now, I'm not going to use the standard Z table. I'm going to be using Desmos. Okay, so these steps, yes, I will show you how to convert into z-scores because Math Excel will honestly ask you, what is the z-score? Excuse me. However, more than likely, when we go to actually calculate that, I will be using this table. I will be using this. And I'll show you that, honestly, we may or may not need to convert to an actual Z table or z-score, okay? So let's go through. I will be going through some of these beginning ones by converting to a z-score and showing you on Desmos how to do that, okay? We're going to be using our normal distribution. Let's get to it. And the survey indicates that people who keep their cell phones an average of 1.5 years before a new one. So before I even do anything, right here, I'm going to underline that because that's my mu. Okay, my mu equals 1.5. Okay, I know that. With a standard deviation of 0.25. So that is my standard deviation. Okay. Now, find the probability or find the area, because they mean the exact same thing. Area and probability are now going to be interchangeable. That the user will keep his or her current phone for less than 1 year. Okay, that's very important before buying a new one. Assume that the lengths of time people keep their phone are normally distributed. Doesn't say standardized, which means we need to standardize it. So my first step is to write out my formula. My formula for a standard normal curve for z-score is z equals x minus my mu all over my standard deviation. Okay, so what is my mu? Okay, my mu is obviously 1.5. My standard deviation is this right here. So I'm actually going to type that in. Now, what is also my x? I like to list out my variables again just so that I know. So let me do that real quick. Now my x is going to be 1. Okay, my x is going to be 1 because it's 1 year. So let's go to 2. My second step is to actually calculate this. So I'm going to do 1 minus 1.5 because that's my mean. My 1 is my x, and then all over 0.25. What do I get when I get this? Okay, I can actually go over here and type it in real quick. I can do 1, well, I'm going to do in parentheses, 1 minus 1.5, and then I'm going to divide by 0.25. Sorry, not 0.25. I'm going to divide by that. So that is my z-score right there. Awesome, awesome. So now what I want to do is just find -2. Now what I want to do is use that -2. Sorry, I already found that it was -2. This is my z-score. Now what is it actually asking me? My third step then is this. It wants us to find the probability that the user will keep his current phone for less than 1 year. So the probability of x being less than 1 year. That's what I really, really want to find. Or, on the other hand, I want to find this probability of my z being less than -2. Now, these mean the exact same thing, and that's the biggest part of this whole lesson. These mean the exact same thing. The probability of less than 1 or the probability of less than -2 as a z-score, they mean the exact same thing, and I'll show it to you, okay? So I go over here as a z-score. Let's erase all this. If I want less than 1, think about it. If I want less than 1, guys, if I want less than 1, what that actually means is I'm going to have my 1 being my max. Why is my 1 being my max? Because I want everything less than that. However, I'm not going to use 1. I'm in a standard curve. Notice that. 0 to 1. So I'm in a standard curve, 0 being the mean and 1 being the standard deviation. So I need to use my z-score here. Okay? But they mean the exact same thing. So now I go and change that max to a -2. And that is my actual answer. So this is 0.0228. This is my answer. So roughly about 2% chance. So the keep his or her phone for less than 1 year. It's about 2% probability that they will actually keep their phone for less than 1 year. Okay, most people keep their phone for more than 1 year. Okay, now watch what I'm about to do here. Okay, I'm going to change this back to 1, but now watch. Let's change our standard deviation and our normal, our mean to our actual problem. We said our mean was 1.5, so let's change our mean. Notice what's about to happen, 1.5. And then let's change my standard deviation to 0.25. So this is what it looks like. But look at my answer. It's the exact same thing, right? It's the exact same thing, which is why these equal. But my mean and standard deviation change depending upon which one I use. If I use this, my value formula, then I have to change my standard deviation to 1.5, or my standard deviation to 0.25 and my mean to 1.5. If I use this, my z-score formula, my z-score probability, I have to change my standard deviation to 1 and then my mean to 0. Okay? Which, of course, I then need to put in my z-score, which is -2. Right? Now, I'm going to be using the next couple examples. I am going to be sticking exclusively to z-scores, but then when we kind of go through them, I'm actually going to switch it up and go through and use my probability of x, using my x, my values like that, okay? Because this is easier. Why is it easier? Because we don't need to do all this junk, okay? If you were doing it by hand, you would do all of this junk. Then you would look on the z table, find your answers, and then boom, you get a probability. But I don't need to use the z table because Desmos does it all for you no matter what. So I don't need to actually standardize this at all, even though Math Excel will tell you to. What I could do is just skip step 1 and 2, find my mean, find my standard deviation, find my x value, and then plug it in accordingly. Not just my x value, but my new standard deviation and my mean. Okay, I hope that makes sense. I could use either one, a z-score, or I could use my x values. Math Excel will want you to use a z-score and convert to a z-score and then find your probability. But honestly, we don't need to do that. We can skip all that jazz, not find the z-score, and then just go straight to the probability if we wanted to. Okay? However, because Math Excel wants you to find some z-scores, we're going to be doing that. So let's go to it. 2016 Honda Civic, which is what I drive. I love 2016 Honda Civics. Well, I like Honda Civics in general, but 2016 is what I have. Automatic transmission gets an average of 31 miles per gallon in the city, driving with a standard deviation of 2.1 miles per gallon. So automatically, this is on average. So this is my mean. And then this 2.1 right here is my standard deviation. So I'm going to do off to the side. My mean is 31. My standard deviation is 2.1. And then what's my x? Okay. So what is the probability that you'll get more than 28? So my x is going to be 28. Now let's convert this into a z-score. Okay. Just because Math Excel will ask for it. So that's what we're going to be doing. Convert it to a z-score. Z equals my x is 28 minus my mean, which is 31. And then all over my standard deviation, which is 2.1. Now remember, I'm using this formula, z equals 28, which is my x minus my mu, and then all over my standard deviation. I'm using this formula, okay? Now, when I simplify that, I actually get negative 1.43. You can simplify all you want on Desmos right here. Absolutely, you can. Does not matter. Okay, but this is negative 1.43. Now, what does that mean? That means I'm going to be using negative 1.43 to find my probability. So the probability of z is going to be greater than, because that's what I want, more than, find the probability that it will be more than, that will get more than 28. Or because I standardize it, more than negative 1.43. Okay, I would go to Desmos right here. I already have this as a standard curve, 0, 1, mean and standard deviation respectively. And now what I want to do is more than that. So if I want more than that, my min will actually be negative 1.43. Okay? So what is that? That is 0.9236. What does this mean? This means on average, what I will get, or on probability, but the probability of getting more than 28 miles per gallon is roughly 92%. I mean, that's very high, which means I will always more than likely get more than 28 miles per gallon when driving my car, which I do, which is great. Okay, so that's awesome. Now let's erase this and let's go to here. So this is a rather long one, but that's okay. So a survey indicates that each trip of a supermarket a shopper spends at least an average of 45 minutes. So off to the side, I'm going to say my mean is 45. Standard deviation is 12. So I'm going to write that down. Okay. A shopper enters a store. Find the probability that the shopper will be in the store for an interval of time listed below. And then afterwards, we want to interpret your answer if 200 shoppers enter the store. So how many shoppers would you expect to be in the store for each interval of time listed below? So let's first start with A. So our A, find the probability of the shopper being in the store for each time interval listed below. So for A right here, my X is going to be both going to be 24 and 54. Okay. Let's actually erase that. That looks ugly. 24 and 54. Here it's going to be 39. So my x is going to change no matter what. So what does it mean here? What this means is after I change it into a z-score, okay, and I'm going to change it into a z-score. That's my first step. When I change this to a z-score, I'm going to take those z's and I'm going to try to find in between those z-scores, the probability. So my first z, let's just call it z1. I'm going to use 24, so it's going to be 24 minus my mean, which is 45, and then all over my standard deviation, which is 12. When I simplify this to b, it's going to be negative 1.75. So that's my first z-score, okay? For my second one, my z2, my z sub 2 is going to be 54 minus 45, and then all over 12. What does that equal? That equals 0.75. This is my second z-score. So now what I want to find? What I want to find for A is the probability between those two values. Okay, so I want to find the probability between my two values of negative 1.75. I have my z-score in the middle, and then 0.75. That's really what I'm trying to find. Okay, so let's go over here. I have my standard curve, and let's change these. So this is going to be negative 1.75, and then I'm going to go to my next one, my max, because I want between 0.75. And that right there is my answer. So I'm going to write it down and round it up. So 0.73333. So this is my answer for A. Okay, that's my answer for A. What is my answer for B? If I just want more than, what this means is a probability of X being greater than 39. But I also need to find my z-score as well. So what's my z-score here of z being greater than what number? What number is that? Well, let's do it off to the side. So z equals, I'm going to take 39. I'm going to minus my mean, so that's 45. And this will be all over 12. When I do that, what I get is negative 0.5. So this is my z-score. It's not my answer, though. Okay, this right here, my probability, that's my answer. But I'm going to put this right here. And so I'm going to do negative 0.5. So now what does that mean? That's actually my max because I want, or sorry, that's going to be my min because I want greater than that. So I want greater than my z-score of negative 0.5. So negative 0.5, I want it to be greater. And so what my answer is going to be 0.6914. So this is 0.6914. This is my actual answer. Smiley face. Now, what does that mean? Let's interpret it. And this is going to be B. I'm actually going to do B here, okay? I'm actually going to do B here. Give me a second. Can I not do B here? Oh my gosh. I don't know if I can actually do B over here, which really pisses me off. So I want to be able to write your interpretation here. Basically, what you do is you take 200. I'm not going to, I guess I'm just not going to show you. I guess I could show you. Let's just do this. What you do is take 200 and then times your 0.7333. And so roughly that would be 147 shoppers. Okay, that's really what it is. And then you take 200 and then times, what's my other probability? 0.6914. And so that's roughly 138 shoppers. So that's what that means. So basically if 200 shoppers, you would expect 200, or you would expect roughly 100. If 200 shoppers, you would roughly expect 147 shoppers in the store. Between this right here, between 24 and 54 minutes. So if you're looking at 24 to 54 minutes, because this is the probability that you will find, that the probability that a shopper will spend 24 to 54 minutes. If that is the probability that a shopper will spend in a store between 24 and 54 minutes, right here, that what we found, then that means if I have 200 shoppers in the store, okay, or if I take 200 shoppers in general, I would expect roughly 147 shoppers in the store that are shopping 24 to 54 minutes. Same thing here. If I take 200 shoppers, and this is the probability that a shopper will spend more than 39 minutes in the store, let's just take 200 random shoppers. I should expect that more than 39 minutes, if more than 39 minutes have passed, I should expect to see roughly 138 shoppers in the store. Does that make sense? So that's the interpretation. I wanted to actually write it out, but it doesn't matter. Okay, so that's the interpretation of it. Very, very interesting indeed. I love that. Let's continue on. What is the probability that the shopper in example 2.1, what we just did, will be in the supermarket between 33 and 60 minutes? So now what I'm going to do is I'm not going to use a z-score. I'm actually just going to straight up show you to use what it's given to us. So probability between 33, let's not use that. Probability between 33 and 60 minutes. Okay, where my mean, just like I'm taking it directly from the last slide, where my mean is 45 and my standard deviation is 12. So now let's go over here. Now watch what happens. I don't need to standardize it. Okay, I don't. And the book may ask you, Math Excel may ask you to, but you don't need to. I'm going to type in my mean first, and then comma, my standard deviation. Okay, I'm going to zoom up here, and that's what it is. Now watch. I want between 33 and 60. And then boom, that is my answer. So now I go over here, and so that equals 0.7357. This is my answer. Now notice here, notice very carefully how I didn't change anything to a z-score at all. I basically took out the middleman, if it were, and then I just plugged it all of it into decimals of what it's given me, and I get the right answer no matter what. If I kept it as a z-score, or if I wanted to do a z-score, I would need to change that to 0, change this to 1. I would need to go through z equals 33 minus, and then I would do 45 all over 12, and then that's my z1, and I would need to find z2 to be 60 minus 45 all over 12. I would need to get these answers, and then those answers would then become my min and then my max, respectively. And then I'd plug them here, with 0 being my mean, standard deviation being my 1. But that takes a lot of work, right? I don't want to do that, which is why I didn't, and which is why I'm trying to show you that you really don't need to standardize or change it into z-scores if you don't want to. Okay? So now I'm going to actually use these, and I'm actually not going to change it to a z-score at all. So watch what I do here. Okay? Triglycerides. Triglycerides, I think that's how you pronounce it. Triglycerides are a type of fat in the bloodstream. The mean triglyceride level in the United States is 134 milligrams per deciliter. Assume the triglyceride levels of the population of the United States are normally distributed with a standard deviation of 35 milligrams per deciliter. So you randomly select a person from the United States. What is the probability that that person's triglyceride level is less than 80 something deciliters, right? Less than 80 milligrams per deciliter. Okay, so what do I do? Well, first of all, what's my mean and what's my standard deviation? My mean, they say, is this. My standard deviation is this, okay? So my mean is 134. My standard deviation is 35. And I want to know x, okay, being less than, so x being less than 80. That's what I want to know. So what's my probability of x being less than 80, given that information? Let's go over here. Let's change this. I'm going to change it to 134. Notice how my graph is changing, right? And I'm going to change this to 35. Now I can always zoom up on that button so I can see my graph very clearly. And now I'm going to change these values. I want less than 80, which means my max will be 80. so that I can see my purple here shading is less than 80. That's what I want. Okay. So now what is that probability? It's right here. And so I'm going to take that 0.0614, roughly 6%. And it's that simple, guys. It is that simple. Okay. All right, let's move on. Let's erase this. Oh man, why? I thought I had another one. Oh, okay. I was like, totally. I have another one. What the junk is happening here? Okay, so person from the United States is selected at random. What is the probability that the person's triglyceride level, given example 3.1, using the exact same thing from example 3.1, is between 100 and 150? So I'm going to use the exact same thing. Okay, so 134. My standard deviation is 35. I'm going to use the exact same information. Now what I want to find is x being between. So I'm going to have x being between. Let me erase this. I want to find the probability of x being between 100 and 150. Okay, what is that probability? So let's go over here. I'm going to keep the same 134 and 135. But I'm going to change this to be 100. And then I'm going to change that to be 150 because that's my max. And that is now my probability, 0.5105. So roughly 51%, okay, of people that you will select at random, the probability of selecting a person at random that will have a triglyceride level between 100 and 150 is around 51%. That's pretty high. I mean, to be honest, that's actually very high. Like pretty much anyone you choose off the street is going to be that, roughly. Okay? Awesome. How's that? Let's erase. Let's go to our summary. What did we learn? We learned about probabilities from normally distributed variables using a table and using technology. Mainly using technology, though. Okay? Make sure you do your homework. If you have any questions, please ask. This is C Squared Mathematics. I'm Mr. Carlson. Make sure you like and subscribe to the video. Peace out.